So welcome to another lecture video series on ECE21115. So in this lecture video series, ang pag-uusapan natin or aaralin natin is Module 5 or the analog filter circuits. So for this episode, pag-uusapan lang natin paano ba gumagana ang isang filter circuit po. And paano ba natin nakaklasify ang filter circuits po. So let's start. So para maintindihan natin kung paano ba gumagana ang isang filter, we need to find an application po. So one of the application is in communications, especially in cell phone receivers. So let's say we have a cell phone that receives a desired signal X of f. So take note, our desired signal is denoted by X of f. It means that we represent our signal in the frequency domain. Hindi ito katulad ng mga signals natin before na nakikita nyo yung sinusoid na ganito ang itsura. Dahil this signal is represented in the time domain. And for this module, most of our analysis are in frequency domain po. So how do we represent a signal in the frequency domain? So let's consider a sinusoid in the time domain. And this sinusoid has an amplitude of 1 and a frequency of 10 kHz. So to represent this time domain signal in the frequency domain signal, gagawin lang natin is ilolocate natin yung 10 kHz na frequency. Let's say it is located over here. And maglalagay lang tayo ng impulse function dito sa 10 kHz na frequency. And its amplitude is actually equal to 1 po. Okay, so isang frequency component represents one impulse function sa frequency domain. So ibig sabihin pala, if we have a time domain signal na merong frequencies na F1, F2, and F3, expect natin sa frequency domain magkakaroon tayo dito ng tatlong impulse functions in F1, in F2, and in F3 po. So balik na tayo. This desired signal po has a bandwidth of 200 kHz and a center frequency of 900 MHz. So ibig sabihin yung information natin is embedded dito sa frequency range na to. So if we have a bandwidth of 200 kHz, so we can say that the frequencies na ating desired signal is from 899.9 MHz to 900.1 MHz. So since ito yung desired signal natin, ito lang po yung gusto nating i-process sa cellphone natin. So ibig sabihin nun, wala tayong pakialam sa signals na may frequencies beyond this range. Dahil yung information natin is nandito lang sa range na to. So we will consider every frequencies na outside sa range na to be an interferer signal po. So let's assume that in addition to X of f, a cell phone also receives a large interferer centered at 900 MHz plus 200 kHz, as we can observe in this diagram po. So since ang ating information is from this frequency to this frequency lang, ibig sabihin kailangan kunin natin tong signal na to and i-reject itong interferer na to. So we can reject that interferer signal by means of a filter. So pag sinabi nating filter, meron siyang mga pinapadaan and meron siyang nire-reject. So ito po yung use ng filter natin. Gusto natin mapadaan lang a specific set of frequencies po and i-reject yung ibang frequencies. So for filter characteristics, so let's first study kung ano ba yung three bands of a filter. So we have a pass band, a transition band, and a stop band. So yung pass band, this is the frequency band kung saan nagpapadaan tayo ng signals. So ideally, dapat yung ating pass band is within the desired signals frequency range po. Si transition band naman, ito yung band kung saan nagta-transition tayo from the pass band to the stop band. And lastly, si stop band naman, it is the response para doon sa mga out-of-band signals natin. So ideally, the response in the stop band should be equal to 0 po. So let's consider yung mga characteristics dito sa different bands na to. So we want to have a flat frequency response. Or it means, as much as possible, yung ating pass band should be flat po. Kasi kung hindi po flat yung ating pass band region, makita natin it will have some ripple. So if we will consider F2, the response at F2 is different do sa response ng F4. Mas mataas po yung frequency response dun sa F is equal to F4 kaysa dun sa F is equal to F2 po. So as much as possible, gusto natin makareceive sila ng equal frequency response or equal gain at that specific band or sa passband natin. Next naman, dapat meron tayong sharp transition band. So ibig sabihin yung slope ng ating transition band should be as steep as possible. Okay? Dahil if our interferer is nandirito, ang mangyayari is the gain during this frequency is higher compared dito sa frequency na yan. Ang nangyayari is merong part ng interferer na hindi masyadong nare-reject dahil yung gain nito is hindi pa masyadong mababa. Okay? So, as much as possible, gusto natin sharp ang ating transition band. So, ano bang itsura ng ideal na frequency response for a filter? So, gusto natin meron tayong flat passband response or meron tayong flat gain dito sa ating passband. And we should have a very sharp transition band. So, ideal slope for a transition band should be infinity or this should be a vertical line po. And lastly, our stop band should be equal to 0. So, dapat meron tayong gain dito and we have a 0 gain po dito. So, take note, yung gain po dito is not in decibels. So, ito po yung ideal filter natin. Pero, hindi kasi natin nagagawa yan. So, let's have an example po. So, in a wireless application, the interferer in the adjacent channel may be 25 dB higher than the desired signal. So, determine the required stop band attenuation of the filter if the signal power must exceed the interferer power by 15 dB for proper detection. So, ang nangyayari daw, mayroon tayo nare-receive na ganitong signal. So, take note again, this is in frequency domain. So, meron tayong interferer in black which is higher by 25 dB sa ating desired signal. And dumaan siya sa filter. And ang gusto nating output sa filter is yung interferer natin is 15 dB below dun sa ating desired signal. So, assuming that this filter is passive, so pag-uusapan natin what's the difference between passive and active filters. So, assuming that this filter doesn't amplify any signals or its maximum gain is equal to 1, ang mangyayari is the amplitude of the desired signal sa input should be equal do sa amplitude ng desired signal sa output. Walang pagbabago sa desired signal. Ang merong pagbabago dyan is dun sa interferer dahil gusto nating isuppress yung interferer. So, what should be the required attenuation para mangyari from 25 dB above the signal maging 15 dB below the signal siya. So, gagawin lang natin is yung idea ng block diagram systems natin. So, let's say meron tayo ditong X dBm for the signal's power. So, therefore, yung power ng interferer natin should be equal to 25 plus X dBm. So, this is the input power for the interferer signal. And dito naman, if hindi naman nagbago yung ating desired signal, its amplitude or its power should stay at X dBm po. So, therefore, ang ating output power is X dBm minus 15 dB. So, gagawin lang natin is parang kukunin natin yung gain. So, yung gain in decibel is just the difference between P out and P in. So, P out minus P in natin is negative 40 dB po. So, take note yung negative dito indicates that the output power level is lower than the input power level. So, tama nga naman dahil gusto natin i-reduce yung power level ng ating interference. So, therefore, the required stop band gain for our filter should be negative 40 decibels. So, okay, so let's continue on the discussion of filters. So, for filters, pwede natin siya i-classify in different categories. So, one classification of filter relates kung ano yung frequency band yung kanilang pinapass or pinapadaan o kaya kung anong frequency band yung kanilang nire-reject. So, first type of filter is called the low-pass filter. So, bakit siya tinawag na low-pass filter? Because it allows low-frequency signals to pass while rejecting high-frequency signals po. So, if we have some cutoff frequency over here, which is FC, so any frequencies below FC, papadaanin niya lang. And any frequencies beyond FC, ire-reject ng ating system yan. So, kaya ang tawag sa kanya is the low-pass filter. So, kung meron tayong low-pass filter, meron din tayong high-pass filter. So, for high-pass filter naman, it allows high-frequency signals to pass through sa ating system. And it rejects low frequency signals po. So, ibig sabihin, if we have some cutoff frequency over here, every frequency beyond FC ay dadaan lang sa ating system. And frequencies below the cutoff frequency, ire-reject ng ating system po. So, this is the frequency response of a high-pass filter po. So, next type ng filter naman is called the band-pass filter. So, dahil nagpapadaan lang siya ng specific band of frequency po. So, ang nangyayari dito, this filter lets a certain frequency band to pass through, tapos nire-reject niya po yung frequencies na out of the band. So, yung out of the band frequencies, these are the frequencies below F1 and above F2. So, ang pinapadaan niya lang na frequencies ay from F1 to F2 po. Okay? So, the figure below summarizes the types of filters po. The last one po is called the band reject. So, for band reject naman, or band stop filter, there's a specific band ng frequencies na nire-reject natin. So, parang kabaliktaran siya ng band pass filter. So, again, this classification po is based on kung ano yung mga pinapadaan nilang frequencies. So, next classification naman is, yung filter ba natin is in continuous time or discrete time. For continuous time filters, it is composed of circuit elements such as resistors, capacitors, and inductors po. So, for filters, nakikita natin yung response niya is frequency dependent. So, for sure, meron dapat tayong capacitors and inductors which are frequency dependent components. For discrete time naman, it is mainly composed of energy storage elements such as the capacitor and a switch po. So this is an example of a continuous time filter. So it is composed of a single resistor R1 and a capacitor C1. While for the discrete time filter, it is composed of a capacitor C1 and a switched capacitor. So meron tayo ditong capacitor plus switch po. And actually, this switched capacitor acts like a resistor. So, for this module, ang main focus natin is continuous time filters po. Dahil medyo advanced po itong discrete time filters natin. And yung third classification naman is between passive and active implementations. For passive filters, it only use passive devices such as resistors, capacitors, and inductors. While active filters use amplifying components such as transistors and op-amps. So as we can observe here, the main difference between a passive and active implementation. So for passive filter, meron lang tayong R, kaya C. Kaya in other cases, we have some inductors. And for active filters, mapapansin nyo, lagi tayong merong op-amp dyan. So usually, it provides amplification po. Dahil the maximum amplification for a passive filter is equal to 1. So what if gusto natin may amplification na kasama? Gusto natin yung amplification natin or the voltage gain is greater than 1. So we need to use an active filter po. Okay, so to summarize, ito po yung different classifications. We have based on frequency response. So it can be either low pass, high pass, band pass, and band reject. So another classification is continuous time and discrete time. So for continuous time, meron lang tayong passive elements. And for discrete time, meron tayong switching na nagaganap dyan. And lastly, we have passive and active filters. For passive, it only utilizes passive elements such as resistors and capacitors, while for active filter, it utilizes some amplifying components such as the operational amplifier. And that's it for this episode po. For the next episode, magpo-proceed na tayo sa filters transfer function po, kung saan mahanap na natin or masasolve natin yung mga cutoff frequencies ng iba't ibang filter po. So, I will see you in the next one. Bye!